Hey guys, if you can hear me fine, good. Otherwise, there's headphones, and we're gonna get going. So, hey everyone, nice to meet you. I am Carl Fluke. I'm a senior developer advocate here with the base team. Been working on it since we launched our testnet about a year ago, and we went live in late July. So what I want to talk about is what is account abstraction. So 100% what is account abstraction from a 4337 EIP level. I want to talk about our Coinbase Smart Wallet, which is kind of like a first-party 4337 wallet. Talk about our bounties, and then talk about some of the fun things that are coming in the next base upgrade. So what is account abstraction? There's a lot of people that have a confusion about this. Some like MPC-based wallet keys call themselves account abstraction, but I want to focus very much so by what the Ethereum Foundation says. And that is that truly account abstraction is using a smart contract wallet. So you are switching from using an EOA to having a smart contract wallet that you can have more programmability and more security and better user experiences by doing so. And throughout this, you'll kind of see some highlights of that. Okay, so what a smart contract wallet can do is today, when you actually have a new person try to do on-chain things with crypto, you have these 5 steps. You go to a dApp, it says, hey, connect this wallet. If you don't have one, it's a Chrome extension or mobile app. And then you have to do some wallet connection approval. Then you have to go to some fiat to crypto on-ramp, get some tokens so I can actually do it, and then I can interact. But with the smart contract wallet, we can simplify that to a drastically shorter onboarding time, and it'll be slightly more integrated. Okay, so let's break down from a technical dev level about what 4337 is and what the pieces are involved. So the main things that we have here are, instead of a user transaction, we now have user operations. So these are mostly the same. There's like 3 new fields that have to do with verification gas. So just know they're different. As a developer, they're pretty similar. The next is you have a bundler. So as its name applies, is it accepts all these user operations from your user and it bundles them into a transaction. So this is a service that goes before the actual blockchain, to where it's accepting a queue of user ops, it's sorting them, and then it's ultimately submitting it as a transaction to the L1 blockchain. You have the entry point. That is just where the bundler submits a collection of user ops. I'll break that down a little bit more in the next slide. Then you actually have the smart contract wallet. So this is a account factory that you make your smart contract from, and this could have a series of plugins. It could be a first party. There's a bunch of providers in this space, and we'll talk a bit about them too. And then lastly, you have a paymaster. So this is a contract on chain that you can send your user op to the paymaster and say, hey, do you want to pay for this? So as a developer, that's probably like the biggest UX improvement, is that you can pay for gas with an ERC20 token. You can make it so the first 5 transactions on your dApp are just paid for you. After 4844, gas is cheap enough now that, like, if I'm in an NFT marketplace, if I want to sponsor 1 cent, if you buy like an over $10 NFT, then you can just remove the concept of gas for your users. So from like an economic cycle, paymasters are much more attractive after that Denkun upgrade a couple days ago. Okay, so what are the actual like end user benefits of using 4337? The first is a simpler user experience. You can just remove gas, or what the idea of that is, from an end user, so they can have much more of like a Web 2 user experience. A big one is multi-call. So by default, when I want to do like a DeFi position today, I go and I say, hey, I want to approve ETH, or I want to approve like USDC, I want to approve USDT, then I do my submission into a DeFi pool, and then maybe I stake it. With 4337, you can actually just make that one approval, and you can have 4 user ops signed in one signature. So the user experience of that is drastically better. I mentioned simplified gas. The other big one is you can upgrade these smart contracts. So if you want to have like I can spend a max of $500 a day as part of your logic for security, you can upgrade that and change that amount. So it is a little more future-proof. Lastly, you kind of have block-level security checks, which is very nice if prices are changing and you want to protect your users. So this is the flow. You have a user operation. You submit them into a mempool for the bundler. The bundler takes those, aggregates them, sends them to the entry point. The entry point essentially goes through a loop of saying, hey, smart account, is this a valid transaction? Can you do this? Do you have the funds? Is it a valid ETH call? And then lastly, it does an execution loop of actually executing that logic. So go do your swap, go do your mint NFT, go do your on-chain transaction. All right. So high level, real quick comparison. On the left is a transaction that you're used to today. You'll notice you have your 1559 priority fees, nonce value, that's all the same. On the right for user operation, the only real differences are, can you see my mouse? Kind of. You have verification gas, so that's an additional payment just to verify that your user op was valid. And then you also have this paymaster and data, which would be, hey, does this paymaster pay the gas for me? And it's just a signature that you can validate on-chain. Okay, so high level, the bundler. What it does is it collects those user operations, it validates them, so it's actually doing like a debug simulation of your transaction. Some basic checks here of, hey, is this a valid thing? It also does a little bit more, where it aggregates them at the paymaster level to say, hey, does this paymaster, can it afford the 10 user ops in my bundle? It also does some things about you can't call a smart contract that is getting deployed in the same bundle. So if you're using a factory to create a smart contract, you can't manipulate that smart contract in the same transaction. The other big thing that is still very growing, if you want to extend bundlers, is there's a reputation system. So if you have like a paymaster poisoning these user ops, there's reputation checks around that, of invalid transactions, things like that. I have the EIP later if you're interested. And then lastly, to protect itself, it does kind of aggregate error codes in these three buckets, senders, paymaster, and factory contracts. Okay, lastly, our next is our paymaster. This is also an area where things can drastically improve. The basic thing paymasters are doing for policies now is saying, hey, I want the first 5 transactions to be free for my users. Very simple. Or I want to pay up to like or I want to pay like $10 of ETH for transactions. Paying with the ERC20 is also very common. That you can maintain a liquidity pool of, hey, here's my game token. I swap it to ETH so I can pay for gas for my users. Something new that's coming is you can also pay off chain. So like if I have a $10 subscription, you could make it so that, hey, somebody just has a credit card. They say, hey, for this wallet, I want $10 of gas to just be paid for me. So user experience-wise, that's drastically better. That's what they're used to in Web 2. So if anybody is hacking on paymaster policies, that's also something I'm super curious what else can be there. I've seen a lot of things with like DAOs to where like for my DAO, if you're doing a vote on chain, the DAO probably can afford to pay for your gas to do your voting, things like that, to where it makes more sense for like the economy you're growing. Okay, cool. I ran through that super fast, which is good. So Smart Wallet is a new release we had with Coinbase Wallet. There's a V4 beta version to where it more or less like white labels a 4337 wallet for you. The main thing it is doing is it removes the idea of a private key, and it's following kind of like a Web 2 world passkey. So a whole bunch of companies now in Web 2 are starting to switch to passkeys for login, like Xbox, Microsoft, Sony, like Target, a whole bunch of e-commerce is moving to it. So it's kind of like a tricky way to get Web 2 people very used to like not having a private key, but it's a passkey. And this is built in with our Wallet V4. The main advantage we see with this is that the Coinbase Wallet SDK is already in multiple hundred apps. So really just upgrading to that V4 gives you a new passkey wallet. And we do want to see some people put this into hackathon projects over this. It is already integrated with like WAGMI VM, so it should be very much so just upgrade the version and you get a free improvement. Only other 2 things to know that are gotcha. You do need to make sure that your smart contracts follow 1271, which is like a signature validation. The docs that are linked later give you good detail about that. And then also, if you're using the Coinbase Chrome extension, we do recommend you disable it, just because there is some collision. We are getting feedback on Farcaster, so if you remember there, that's kind of like our preferred support channel. Okay, the real magic feature that we can have with this is what we call magic spend. So Coinbase has a smart contract that we're calling the piggy bank, to where we let users actually use their retail balance on chain directly. So if they have ETH in their retail, we kind of just have a piggy bank of like 100 ETH sitting on chain, and we'll debit their account on chain. So you skip the whole, like, I have to transfer to this wallet to use it. You can just directly use your retail balance. So that's kind of like a magic unlock that you can't do with an EOA. We are going to extend that further to where, like, you can use your payment methods, but retail balance was the starting point. All right, I made good time. So what's next? This week, 4844 came up, which was awesome. I think right now we're still at like 1 cent NFT mints on base mainnet. So that was like an order of magnitude improvement for gas costs. Love to see it. I was kind of like doubting how much we'd seen an improvement, and it's doing well. Specifically for 4337, this also makes it so that the gas overhead of account abstraction is drastically lowered. Something that's coming up in our next upgrade is EIP 7212, which is a precompile for the passkey curve. So right now, smart accounts, your gas is more or less like 80% more than an EOA. Once this precompile goes live, it should drop to be like 10% more. And that'll make it so like the average user won't really notice the difference in between an EOA and a smart account transaction cost. There's a couple EIPs for talking about migration that we're considering. If anybody has thoughts about this, come talk at the base booth. But there's two main ones. One is like, hey, I have an EOA and I want to upgrade it to a smart contract wallet. So there is an opcode to do that, just to make that drastically easier. If we want to make smart accounts the default, this would help us do that. And then lastly, native account abstraction is a roll-up improvement. The team has a lot of debate about it. If you have thoughts on that, that thread is also moving forward. Okay, there's also two big plugin architectures that are on debate. Alchemy is leading 6900. They have a couple plugins out there. Biconomy is doing the 7579. If you're hacking, we are interested in more people making plugins for smart contract wallets around security, around transaction maximums, auto swapping maybe, to where like I want this account to only have USDC in it, things like that at the smart contract level. So to bring it back to like Base's mission about why we care about 4337, we want to have 1 million developers on chain. One stat that I still think is crazy is that there's only like 22 million software engineers in the world. And by 2030, it's supposed to be 29, which is crazy that we have how important of a job it is. There's so few working on it. And then lastly is bringing our Coinbase users on chain. And we really believe like a global on-chain economy will happen on chain. For 4337 world, I want to give a big shout out to all the partners that have been building on it for the past year, since ETH Denver last year. Worked with all these guys. Great ecosystem. Okay, so for our bounties, just to give a little more detail specific here, is our first one is build an on-chain product or tool. So this is very generic in general. We just want people to build a product on Base that a normal person out there in the world, like go down the street to somebody in London, and can they use your product? And hopefully it, fully shows that on-chain can be better than like what we currently have in Web 2 world. And then, lastly, try to fill any gaps that are not on Base. Then the second one is there's kind of very different criteria here, so you just need to hit one. Best use of 4337. So that can be using our cloud bundler or paymaster. You can use that with like Alchemy Account Kit, Pimlico, EtherSpot, any of the providers I showed before. You could make a tool that makes it easier to use account abstraction in your dApp. So like make an improvement in using like Rainbow Kit or some other login provider that makes it dead simple to actually use AA by default. And then lastly is use that V4 of wallet to use kind of like the white labeled version of a passkey wallet. If you're doing a consumer product, that's probably the most straightforward, because you would, as a developer, it would just be like doing a transaction. Here's some QR codes of like the GitHub repos for that, if anybody wants them. Okay. And I did that super quick, so that was good. I do have time for questions, which is perfect. So anybody have questions of 4337 or of the very complicated multiple choices we have of Paymaster Bundler, regular AA, or using the V4 Smart Wallet? Or if anybody has questions of like the base future roadmap of what we're working on.
Hey, great presentation. I'm not used to not hearing myself.
Yeah.
Can you explain a little bit more about what you mean around native account abstraction? Maybe you can just expand on that.
Yeah, 100%. So this is a proposal to actually make it so that we change the default transaction type in Ethereum to include 2 or 3 new types that are AA specific. So when I showed that user op example, there's like new fields. This is way back. There's new fields, so there's 3 kind of like additional parts that would actually be in the default transaction signature, and then the transaction type has 2 new ones to say like simulate and actually do a user op directly. So yeah, very much so like Web3, Ethers, VM would all just be user ops by default. Yeah. I think realistically that's like a year and a half out, but I know the Ethereum Foundation has been doing a lot of good research on that.
Yeah, one thing I don't understand is we, at the beginning you said we would have a bunch of user operations and they're signed, right? Does that mean the user still has to create an EOA account to have those signed operations that the the bundler would then bundle into the smart account? How does that work?
Yeah, so the website will still sign them in some way. In the smart wallet example, we're using a passkey. There's a bunch of MPC or other key providers out there, like Privy is a big one we've worked with, to where you can have like an EOA equivalent hidden based on your dApp. So you can do like your login with Google, login with Apple, and it'll give you a temporary key and you'd sign with that. But as a developer, you can sign that in the background on behalf of your user.
Thank you.
Yep. And then the other big thing that relates to that is there's also this concept of session keys as a plugin. And that is kind of like the even better way to do this is you could actually make a temporary signing key. So like when I start a game session, you do one signature saying, hey, this game session token's valid for an hour up to a certain amount. And then you just sign in the background for the rest of the experience. Yeah. All right. There's no... Sorry? Yes, for Alchemy, and so does Biconomy. There's a couple other providers that have it, but those were the 2 that are leading these EIP 6900 and 7579.
One more question. So it seems like 4337 is focused on you have a private key. You can get that through passkey or some other way. And can you touch on how we can connect this with token-bound accounts with 6551? That it feels a bit more seamless for apps because you are only delegating the ownership and the authentication of an action based on who owns the underlying NFT, for example.
Yep.
Is there a way these 2 can we can connect both of them, or would they be just completely different?
You can give a 6551, I call it a backpack wallet, to a smart contract wallet, and the smart contract wallet will own it. You can make them work together. Using a smart account, it would simplify the whole like transfer ownership or give or delegate control of. I think you would not want to use those interfaces if you're using a smart account. You'd let the smart account take advantage of that. Yep. Okay, perfect. I'm at time. Thank you all for coming.
Okay. Yeah. Okay. So my name is Blessing. I'm senior dev for Circle. I'm based there in London, and I've been working with Circle almost 1 year now. So today I'm going to walk you guys through how to create gasless transaction with Circle's Web3 services, and kind of talk about how that weaves into what you are going to be, the project you are going to be building for the Circle Bounty, and I'm going to show you a quick demo on how to create that as well. So in case I don't have time to take questions, I'll be right outside after the presentation, and we could chat for questions, or you could also come to the booth. I'll be there all day today, tomorrow, so I'll be happy to take your questions as well. All right, jump into it. Put together this stack diagram to sort of explain to you the Circle technology stack, and that would help you think through how to build your project for the bounty prizes. If we start from the base, you see all the blockchain networks that USDC is on, and that's you could have your EVM compatible blockchain on top on that, and then on top of it, you've got the stablecoin protocols. You've got USDC, you've got ERC, and you've got CCTP. If you're familiar with CCTP, show your hands, wave your hand. Oh, okay, amazing. So you've got CCTP, and to just explain really quickly what CCTP does, CCTP lets you move USDC across chain, opening up liquidity and helping against the liquidity fragmentation, because you could send from one chain to the other chain. If your USDC is on one chain, you could send to the other chain. And then on top of that, you've got the Web3 services, which is kind of like the Circle's new product offering that offers APIs where you can embed wallets, that's programmable wallet, and then where you can build, deploy, and manage smart contract, that's the smart contract platform. And we've made this so easy by just with a single API call, you're going to be deploying and minting your NFTs. And also below that, you've got the gas station, which lets you sponsor network gas fees for your users. Thankfully, The first presentation already kind of gave us the technical details of account abstraction. Now I'm coming to show you kind of like the demo of how you can send USDC from one wallet to another wallet, sponsoring the gas fee. So, and on top of that is your application that you're going to build during this hackathon. So you can kind of see how the whole Circle technology stack connect together to basically serve your business offering and the application that you're going to build during this hackathon. So I've put together a quick demo, and this demo I'm going to show you how to easily use the learning platform that we've prepared at Circle to create a gasless transaction. And this learning platform helps you learn how to either work with the user-controlled programmable wallet. Programmable wallet is divided into two. You've got the user-controlled programmable wallet, you've got the developer-controlled programmable wallet, and then with user-controlled programmable wallet, I'm just going to show you in a very few steps how you can easily use that. So the first, we've got about 7 steps here, and the end of this step is that you're going to create your first transaction, and transaction will be from one wallet to another wallet, all gasless. So the first thing you're going to do right here is to get your API key, and to get your API key, you go to the console. So this is the console. It's console.circle.com, and then all you need to do is go to the API key section, click on create API key, and when you click on create API key, you just put in an API key name. So let's put Arc London. And so with that, I can easily create a standard API key, and this I can just copy this API key, and that's what I'm going to use to show you how to interact with the APIs pretty much easily, and then be able to send your gasless transaction. So I've copied these. For the purpose of this demo, I'm just going to keep it in this Google Docs so that I have access to it. But if you go back to the platform, the next step where you are going to basically use your user-controlled programmable wallet is to acquire what's called the app ID. So the app ID, it is a recognizer that sort of identify your application or your application that you are essentially building in the Circle platform. So you've got the API calls, sample code that you can just copy and interact with in your application as you hack, right? So you can just copy this, but this platform is built so that you can interact and test out how all this thing kind of works. So I put in my API key here, and then I'll hit the execute button, and that would give me my app ID. So with my app ID, I can copy it again and just put it in this doc so that we can have access to it in case we need it. So I've sort of I'll close this so that it doesn't get in the way. So I've acquired my app ID. The next step to do is to create and initialize the user. So for example, if you're building a mobile or web application, once your user signs up, the next thing you will do is grant them a wallet that they can use to transact on your platform, and that's what the next step is going to go over. And I'm going to show you examples of snippet API calls that you can just copy the code and just test it out in your application. So all you need to do right here is create a new user. So to go through a quick steps of what's entailed creating a new user, you create a user, you acquire session token, and then you initialize the user. Apologies if I'm working super fast, it's because of time, but I'm around to chat a bit more after this. But essentially what you need right here is that to initialize your user needs a way to be able to, you need a way to be able to identify your user, and that's where the user ID comes in. And I'm just going to generate a quick user ID right here using this example platform, and then I'm just going to put that in right here, and that's the user ID. So you could embed the code into your application where your user gets a particular user ID. So I'm going to use Machich Mumbai blockchain, and that would give me my user. So you can see right here that the response I got back is a user token, encryption key, and then a challenge ID. More on challenge ID in a bit. I'm going to tell you more about challenge ID. So the important reason why you need challenge ID is that you need to be able to interact. You need your user you need a way for your user to be able to interact with your application, and then you need to be able to grant that securely. So they need to complete what's called a challenge in a way that if your user was to send USDC from one wallet to another wallet, you need to be able to know that it's your user, it's not any other person. So that's why you would add a challenge, and we're going to basically create a challenge, and we're going to complete a challenge. So with this snippet, it's been filled with the user token, the encryption key, and the challenge ID that we retrieved in the previous step. I'm just going to click the execute button right here, and what you see right here is kind of like how you would offer this offering to your user when they want to create a transaction, or when they want to create an account on your platform. They need to create their own PIN, and with that, all you need to do is set a PIN. I'm going to create a PIN right here for the purpose of this demo, and I'll enter the PIN again. So you can see that we're already presenting a sort of like a Web 2 interface that almost everyone is familiar with. And to his point in the previous topic, you can just walk down the street of London, and then you can let your user transact on-chain without even realizing that they are using on-chain operations. So I've created my PIN. Next thing is set a recovery question in case your user forgets question, or you forget the PIN. You can set up a question. So I'm just going to put in random answers. So let's put in London for this. Let's put this London so that I differentiate them. I'm going to put in favorite sports team. I'm going to put in Manchester, and then I'll put in City, right? So let's complete that. So your user, they've got their recovery questions, and they can easily retrieve their PIN in case it's forgotten. So this is kind of like the last step where you give them to say they agree, and you continue, and the challenge has been successful. So your user can go onto the platform to transact, send money from one USDC to another, send one USDC from one wallet to another wallet, right? So once that's complete, let's check the wallet status. And to check the wallet status, you need the user ID, because that's the user ID that indicates the user. So you hit the execute button, and you can see right here that we've got our wallet address, and then we've got a particular blockchain, and you can see what's written SCA. That's the smart contract account that is assigned to the user, meaning that you can send gasless transaction, sponsoring the gas easily. So I'm just going to copy this information, and I'll put that in this document, right? I'm kind of walking through all this really fast, and I'll copy the address because we need to use the address to send transaction shortly. So I'll copy the address, and then I'll put that. So we need the wallet ID, right? I'll copy the wallet ID right here. And the reason why you need the wallet ID is that this platform is built in a way that would offer you 10 USDC, 10 testnet USDC for you to sort of interact and understand how to use the platform. So I'll put in the wallet ID here and hit the execute button. And you can see that we've sent you 10 USDC so that you can play with that testnet USDC and transact, right? So in the next step, I'll sort of initiate a transaction. And to initiate a transaction, we're just going to send from one address to another address so that you can see how to create your first gasless transaction. So these are API sample codes. We've got developer documentations and videos as well that you can watch to understand how to build with this more deeply. So we're going to send 2 USDC from this address to the same address just to test out. Okay, that's the wrong thing. Let me just copy the address right here. And right, so we need the token ID. We need to get the token ID right here. So we've gotten the token ID, and you can see that this is a USDC token. This is the Matic token. You can see that it's 0. So we're not even using that to pay for gas, right? So all I need to do is copy token ID right here, and then I'll take it down right here, token ID, and I'll go back and copy the address, and then I'll put that in right here, destination address, and let's send to USDC. Right, so I'll hit the execute button, and the transaction has been created. The user needs to complete a challenge so that we verify that it's the real user that is using your application. So I'll hit the execute button, and remember the password we set in the previous step. We're just going to put that right in here, and in case your user forget the PIN, they can easily get that with the recovery question. And you can see that challenge has been successfully completed. Let's go back to the console. and you can see all the transaction that was created. You can see that I sent 2 USDC from this wallet to the other wallet, right? And that's completed. And if you click on one, if you open it, you can see the transaction fee, you can see the user up hash, you can see all the necessary information, and that's how you create your first gasless transaction using Circle Web3 services platform. So I'm at time now, but I'll walk you through the next thing that you need to know, which is the price pool information that you need to be able to partake in this hackathon. So if you come to Circle price information, you can see a lot more about this, but then I'll just quickly walk through it. We have 4 pools of the hackathon prizes. All you can see right here, the first one is the cross-border payment, which is the best application for any payment infrastructure, peer-to-peer, where it facilitates international transfers across countries, and you can connect that to reward use cases, such as using the smart contract platform to mint NFT, which grants other users kind of like access to get discount from other businesses. So you can sort of connect this transaction with reward use cases, but the gist of it is that you must do all this information for you to be able to win $2,000. And the next prize pool is dollar access. What that means is that you create a mobile or web application that gives your user access to USDC or USD, and that sort of opens up global access with the digital dollar and gives them financial stability. We've included a couple of examples and also recommended tools that you are expected to use, and this is the qualification requirements that you need to be able to qualify to win the prize. And the third one is the crypto capital market, which lets you trade with USDC, give people loans with USDC. And the important thing is that all this must be built with the Circle product, that technology stack that I showed you when I started this presentation. Think through that, and that would help you understand how to build. And the last one is the best emerging use case. We have a lot of people that have met here that want to build with the Forecaster tool, social media, Web3. A lot of people want to build AI use cases, and we have a ton of examples right here. The CCTP for cross-chain, essentially new application that it's not common. It's what people are already talking about, account abstraction. It's going to help us with user experience, with the user experience challenge in Web3 in the future. Just really nice emerging use case that is so special with all the Circle Web3 services. The first prize gets $2,500, and the second prize is $1,500. And you can see right here, we have all the resources that you need to be able to learn. We have videos, we have documentation, we have the Learn platform that would essentially teach you how to build with Circle. And then you fill a survey as you're about to submit, because the feedback is also part of the important criteria for you to be able to win. And this is the survey link, right? And that's the prize pool information. I just want to leave this with you, that remember that at the heart of every line of code lies the potential to change the world. So as you build with this hackathon, I invite you to build with passion, and I wish you guys all the best. Thank you for the presentation. So I'll hang around if you have more questions, but I think okay, 3. Okay, yes, I'll take one. Yeah.
Is it possible?
Yeah.
It doesn't work. Oh, does it?
It works. Yeah.
Is it possible to get more access to more blockchains than just Avalanche and Polygon? For example, Base.
So that's the thing. We're working on more blockchain, but for now, this is what we support, and we'll share more announcements when we go live on other blockchains.
Okay.
Yeah, but it's on the roadmap. We're extending this to more blockchain. So if it's not yet on your blockchain of choice, we would announce in the future, because we're working on a roadmap.
So it's not available for hackathon, right?
Say again?
For the hackathon, we don't have them yet.
Yeah. It's for the Web3 services. We've only got that on ETH, on Polygon, right? Yeah. But for the hackathon, it's not yet available.
Thanks.
Yeah.
One more question? Good.
Thank you, guys. Thank you, everyone. It was really nice coming here. Thank you. My name is Boris Polania. I'm the dev rel from Near, and we are going to talk about hacking with chain abstraction with Near. And I will talk a little about Near first, and then I will go into the chain abstraction part. So let me fix something here. It should be here. Oh, come on, there you go. Okay, so I don't have a lot of time, so I will make the Near part very quick. Why Near? In case you don't know Near, we are layer 1. We are natively charged, so we are really fast, really cheap. The account model is very unique, so it's very well suited for abstraction. The charging model makes us infinitely scalable. We can scale very easily. We just recharged last week to our 5th chart. We have a very good ecosystem, very good support for dev tooling. And onboarding, we are making all that we can, so you can not only yourself, a developer, onboard into Near, but you can onboard your users into Near when you deploy your application, you create your application. So what is chain abstraction, right? So it's a multi-party computation technology we have created that enable you as a developer to integrate multiple protocols, to support multiple protocols, multiple chains, right? So don't eliminate. It basically eliminates your the risk of bridging, and it makes you easier to unify your user experience. Basically, you should be able to sign. What this means, you should be able to sign transactions from Near, from mostly any other blockchain. So your user, if they deploy a game, they should be able to sign transactions in any blockchain using only the Near ecosystem and the Near set of libraries, etc. So that's basically what is the chain abstraction about, right? So you can any EVM compatible network, even Bitcoin, Doggy, Ripple, whatever, you can just use Near to unify the user experience and reduce the risk that comes with breaching assets, right? So again, simplify the user experience. You can abstract, you can hide all the complexity from your users. That's the main thing, right? You don't want users to keep dealing with the connecting the wallet, paying the gas. This is what we're trying to eliminate. You can use some of the services we have, like account recovery and stuff like that. You can eliminate you can delegate decide who pays the gas, so your user doesn't have to pay the gas. And we just said you have the cross-chain control. So the components that we have for the chain abstraction thing is the relayers. Basically, when you deploy a relayer, you will be able to cover gas fees. All this works is you will be able to cover the gas fee, or decide who pays for the gas. It could be either yourself or a third party. That's what we're trying to. I will show a little. I don't have a lot of time, but I will show later a little code for each one, so you have more idea what it takes to implement. And it will be thinking on the hackathon, like an easy way because the bounties. I will talk about the bounties. One of the bounties is related with this. So the relayers is to cover the gas fees. So you decide who pays for the gas. You don't want your users to pay gas. You can pay it yourself or any account you decide who will be paying the gas. So the signatures is one account, multiple chains. Basically, You sign the transaction. I will show that code too. You sign the transaction. There are like 5 steps. It's a meta transaction at the end. What is happening is a meta transaction, and basically that's what will allow you to do that. You will be able to sign a transaction in another blockchain. You sign it from near. Sorry, I don't know what happened there. And then we also have the fast out. So if you want to do email onboarding, like Google and stuff like that, OAuth is standard out. You can do. We have a set of libraries that you can do it. So you don't have to relay in a centralized service to onboard. Basically, it based the authentication on a near account. So I will show a little code about this too. Okay. So the bounties. Well, I will go to the bounties and then I talk to the code because I want you to see the code, an easy way to to deploy for the hackathon, right? That's why we are here, right? So we have 2 bounties. One is boost your startup with Horizon. So if you have a startup or a project already running, and you integrate any of the stack from near, it could be Aurora, smart contracts, Boss, you will be eligible for this bounty. It's a $5,000 bounties. We usually give one first or second, but if there are not good projects, we just give one. If there are many, with up to 3, no more than 3. Usually it's 2. Most of the time it's 2. And then we have the chain abstraction, the chain signatures. This, if you use any of the components I was about to show, like the fast out, or the multi-chain, or the relayers, you should be able to be eligible for this specific bounty. So, well, this is us. We have a Telegram group just for the hackathon, where the developers are here. If you join, we have support all the hackathon. We will put in all the libraries. For example, we just released a libraries like 2 days ago when you can pay the gas of any blockchain in near. So if you integrate a chain, you can pay the gas in near, right? So that's the stuff like that we will be posting there. They're very beta thing, but you will be able to use it. So let me show you a little so this is building a meta. You need to do the meta transaction doing a relayer. So the demo we have is using Next.js. So basically, you need to set up. You create an account that is really an account that will be, taking care of the gas, and you create you put the private key, and then you just create the routes. Is that Next.js, right? So you need to create the routes where you will receive the requests. The code, it should be very copy pasted for you if you want to use it. You just need to make sure you have a near account, you just create like this, the Next.js server. It's a Next.js example we have here, and then you have the client code. So you have 2 parts on the client code. You need to sign a delegated transaction. This is the meta transaction. You have to sign the transaction there, and then you use this is code that you can literally copy paste to sign the transaction, and then you need to use the relayer you created up here to send the transaction, right? So again, we'll be in the booth. If you get stuck here, we can go more detailed, but I don't have like 15 minutes, so I can go through all this code. But this is what you need to do. You create the Next.js, you create the routes, then you have one part that will sign the transaction, the meta transaction, and then you use the relayer to submit the transaction to the other blockchain, right? It depends on where you want to sign where exactly blockchain are you using to integrate, right? That's it. That's all what you need. You will have access to this, but we'll be there. We can help you if you get stuck. Then you can do the chain, for the actual chain signature. There are 5 steps. You need to figure out, first you need to derive the address on the other chains, right? So that's the first step you have to do. You have the example here. That's a little complex, but if you get stuck, come to us. Then you have to create the transaction. This is a meta transaction. You create the transaction using the address you just derived, and then you request a signature. So you call the near the multi-chain is a library, it's a SDK. You use that library to request a signature in near for that transaction. Then you do the reconstruction of the signature, and then you use the relay to send the transaction. This one's a little tricky, but we have a step-by-step here
I only have 5 minutes. Okay, I only have a step-by-step here to how you can do that. And again, we'll be on the booth to do this. And the last part, I don't know what is here. I want it here, but I show you here, is the fast out. So the fast out SDK is an SDK that you can route, is ideally is you want to sign up your users using their email. So we use, it's a multi-party computation, the security using MPC, and then you just need the signer app. You require the recovery service, and you need again a transaction relayer, right? So the relayer is basically you will need to use it everywhere. It's done in Next.js, so it should be, if you are familiar with React or Next, shouldn't be that hard. But still, the sample codes are here. We can always help you. So you have the code here. You require some keys that we can probably find. We should be able to find one for you. But this is a very long example. So just come to us. I won't be able to. But the idea is here that you create an email, or the user will be able to recover the access. That will be actually the benefit, right? And it's still, kind of decentralized. So that's one of the benefits of using the fast out SDK. So we also have the boss. I mean, if you want to use, there are other things that you can do. You can do boss, that is like React on chain. I don't have time to go through that, but that's something you can use for the other bounty. But if you can, we really want to focus on the abstraction part. That's the things we want for the bounties. So these are the three components. You can sign meta transactions. You can do the fast out, or you can do the multi-chain, the chain signatures. That's basically what the things what you'd like to focus. Make sure that building a relayer, the meta transaction. This is only for free transactions on Near, right? If you want to create an application that the user doesn't pay gas on Near, you use the relayer, the simple relayer, or you can use the multi-chain, so you can handle the signatures on other chains. But even so, you can do it so they don't have to pay the gas in another chain. It will be crazy for you to pay it, but you can pay the gas for them too. But the idea is they will be able to send transaction here. And so that's the three components we want you to use for the hackathon to apply for the abstraction bounty. They are a little coding intensive, but again, please stop by in the booth. And I don't have much time left, because I want to use a couple of minutes for questions. So please, before leaving, join the Telegram group, where we will be giving all these links to these libraries and the SDKs and all the things. We're also we be giving some giveaways during the hackathon and stuff. So follow the Telegram group. So if you have any question, I think we still have a few more minutes to do that.
Thank you very much for the talk. I'm a bit curious about account abstraction. How does it work? Especially if, for example, when I create a Near account, does it create, for instance, an Ethereum?
Sorry, man. Can you repeat it?
Yeah. So I have a question regarding when you create a Near account, does it create an Ethereum wallet address and also a Bitcoin, for instance, address? Like that. And my second question is, could we aggregate a different wallet? So let's say, for example, I have a Bitcoin and Ethereum wallet. Is it possible to, when I'm creating a Near wallet, I can put the two wallets together for my Near account?
Well, not like that. If you want to integrate like a Bitcoin address, you have to, the first thing, it's a meta transaction, right? So you need to first to derive whatever address from the libraries we have. You can see on the screen, we have a code, a sample code, how you can derive addresses in other chains. So with once you derive, you first create the transaction, sign it, and use the relay to send it away. That's the way you link it. Not just By creating the account in near, you cannot directly link. Basically, you have to derive, create the meta transaction, sign the transaction, and send them to the relay. That will be the right way to do it. Probably the only way to do it. Yeah.
Any more questions?
Yeah, I'm very interested in meta transaction. You said that it's possible to communicate with other chains, and is it possible to deploy some bytecode on Ethereum network? So I have a contract, I want to deploy it to Ethereum and pay fees in near. Is it possible?
Yeah, I mean, I will need to understand exactly the contract, but you should be able to sign the transaction in near, and pay the gas in near. I mean.
So the contract deployments is also covered, so I can deploy contract using meta transaction.
To be honest, you got me there. If you want to deploy and pay, I need to double check that part. I know you can pay the gas for the transaction you sign, but probably if you can put the bytecode and the transaction inside the deployment of the contract, yeah, probably that's possible.
Okay,
but
thank you.
Yeah, if you are in the Telegram group, we can ask directly to someone that is more involved with me than the. Armando is there with the guy. He can, yeah. Any other question? Okay, guys. Well, thank you. Please stop by the booth and.
So, hello guys, welcome to the workshop. So this is, it's going to be a Chiliz workshop. We are talking about Chiliz Chain, which is our layer 1 blockchain, which we launched almost a year ago now, maybe just over that. And who is Chiliz? So who am I? So I am James, I'm the senior product owner for the blockchain team at Chiliz. We also have in this room with us Cyril, who is our lead blockchain developer, and Anna, who is our director of operations. You'll be hearing from her as well a bit later on. And so what we're doing here, so who is Chiliz? Chiliz has been around for about 5-6 years. We started off making partnerships with clubs. And with these partnerships we made with clubs, we created a new form of asset, which is a fan token. So with a fan token is an ERC20 token, which essentially allows users to engage with the club, right? So we created this relationship with clubs where through these Web3 tokens, clubs are able to allow their fans to engage with them and earn rewards, be it tickets or money can't buy experiences. So what we did is we managed to get about 2 million users on our fan engagement app. It's called socios.com. And we realized that we wanted to start opening up the ecosystem to allow others to also create utility for our fan tokens, create their own fan tokens, maybe look at different sports that maybe we aren't looking at, entertainment. So we created this layer 1 blockchain called Chiliz Chain, which is an iteration of our old private blockchain. But obviously this one is public. It's an EVM compatible chain. It's a fork of Binance Smart Chain actually. And essentially what we're doing here is we want you guys to kind of come build some ideas. We are focused on mainly sports and entertainment, but we're also looking for tools, right? So we want to make the developer experience easier and easier to build on our chain. So we also look for that kind of stuff. And essentially, this is what we're looking for here. So I've created this page. It's a landing page for ETHGlobal London. It should kind of condense a bit the docs so that you have everything you need to get started right here. We have also a link to our workshop video that was published on the YouTube channel, and we also have our price categories. So what we're looking for is 2 different specific categories. One of them is fan token utility. So we want to get real life use cases for our fan tokens besides the ones that we've already created, and add more utility, right? So we want to utilize these fan tokens on different platforms, which can be anything from token gating, live events, whatever comes to mind. And we have first, second, and third prize for that pool. We also have a second category, which is SportsFi. So we want to create platforms related to sports and entertainment on the Chiliz chain. It doesn't have to be related to fan tokens, but any new kind of idea that can create Web3 experiences with sports and entertainment on our blockchain. We added some examples, so DEX, lending, social fi, pool betting, lossless betting, and anything that comes to mind, right? So we had some ideas, like for example, oracles for sports data. So whatever is related to sports and entertainment, and you think will benefit the network, we're ready to look at it. We also have a pool price. So what we're looking for in the pool price is just successful deployments on our chain. So if you have a project that you're building that maybe is not that related to sports and entertainment, you can deploy it on our chain and you will be part of the pool price as well. We have some useful information. So our testnet is called Spicy Testnet. This is where we're looking for people to deploy. There's no need to deploy a mainnet. You can just deploy on the testnet. It's enough for us. And we have some links for the block explorers. Actually, I'll update this because this is the block explorers for mainnet, so I'll add the ones for testnet as well. Our links to the docs, minimum gas price, and some other information that might be useful whilst you're hacking. some links for our test net. So we have a faucet. We have two faucets actually. One of them is run by us, another one is run by Tatum. So you should be able to get chilies from there. And if you need more, just let us know and we can provide. We also have a faucet for fan tokens within the same. So the spicy faucet, you'll be able to get fan tokens from there as well. And we have some links to available tools that are some tools that are available on the network, like Morales, Tatum, Third Web, Word Connect. We have PETH as an oracle, but it only provides price data. But we also have random number generation from PETH, so it might come in handy for some project that you'll be building. So that's a quick rundown. We are a layer 1, so an EVM compatible chain. It should be pretty straightforward. There's not much technical stuff that you might, if you're used to deploying on EVM, it should be the same experience for us. But if you have any questions that I can answer, I'm happy to do it. Yep.
Any specific RPC you would recommend? Any specific RPC you would recommend? Like the spicy RPC, is it stable usually?
Yeah, the spicy RPC would be the most stable one. We had some issues recently with public node, so I would stick to spicy RPC for now. But both should work technically. Any other questions?
Excuse me. Yeah. So how do we verify contracts? Is there a verifying API?
So maybe Cyril. Sorry. So you can use the Explorer. I think there's a hard hat with Chili Scan. No.
Yeah. I can find the verification API in the docs.
You can't find it in the docs. Which one are you? Scan.cheese.com or sorry, spicy-explorer or testnet.chiliscan.com.
Scan.chilis.com.
So scan is for mainnet. We have spicy-explorer.cheese.com for testnet, and there should be a guide in the docs.
Okay, I'll find it out.
If not, you can just come to our booth or ping us on Telegram. We have a Telegram group for hackers as well.
Do you maybe have any examples from like previous hackathons where teams successfully integrated the Bioconomy SDK for chilies for account abstraction?
So far we haven't had. So our last hackathon, Bioconomy was not yet available. So we didn't have really much people using it, but we've tried it out quite a bit ourselves, and it should be working easily. That's a good point, actually. If you want to use account abstraction, we have Bioconomy available on the chain. So. If we don't have any other questions, we can close off early. You can come ask me now or at the booth. But yeah, good luck, and we're excited to see what you guys come up with.
Hello everyone, I'm Chef Momo, a product manager at PancakeSwap. Today we'll discuss PancakeSwap's journey, our latest iteration of the protocol, that is the version 4, and what's in it for you as developers. So we launched V1 in 2020, end of the year. We were the first DEX on BNB, and we launched the V2 AMM style. And then shortly after, we launched in 2021 the version 2, which supported the stable swaps. I also implemented the cake buyback and burn. And between V1 and V2, we achieved quite a few milestones. So we were the first $1 billion liquidity project on BNB chain, and then also reached a peak TVL of around $8 billion then. Also held like 50% market share of the total volume across DEXs. Last year we launched version 3, which supported the CLMM type curve and expanded on multiple chains. We are on a total of 9 chains right now, and we also expanded on multiple product verticals such as gaming, derivatives, and staking. On top of this, Cake turned deflationary last year, with meaning that we are now making more revenue through our product verticals as compared to what we are giving out as incentives. So today we are here to announce PancakeSwap V4, and so let's see why we need a version 4, right? So the current version lacks the flexibility and the adaptability to kind of support any pricing curves or add any custom features on the go without re-implementing the core protocol. And it also kind of has huge gas fees, and it's not like perfectly optimized. So essentially it becomes difficult for developers and DeFi protocols to benefit from our user base and deep liquidity and build upon us. So what do we want to achieve with V4? We want to become the core liquidity infrastructure to support the DeFi ecosystem, and then simplify product development and innovation for developers and protocols, and also introduce gas optimizations for scalability and mass user adoption. And how do we do it? Through a 3-layered modular architecture. So there are like separate modules to implement the AMM models and the custom features through the custom layer, which is the hooks. And we have also implemented gas optimization techniques like singleton, flash accounting, and ERC 6909 support. Right, so we'll look into each of these layers from here. The first one is the accounting layer of the vault, where vault is basically the point of entry and exit for all user operations, and it stores all the tokens balances in this particular contract. So how the flow works is that the external contract or the caller requires the lock with the vault first, and then performs any action such as swapping or liquidity adjustments. Then further, the pool managers executes those actions and then informs the vault of any balance changes and the net settlement amounts of the currency. And then at last, the vault kind of settles it back with the caller in total, right? So this is how broadly the vault works and maintains the ledger of all the transactions. And now the gas savings come with flash accounting implementation, which we'll discuss later on in detail. So from here, I'll walk you through like by each step, and then maybe with some code snippets to make it clear on how it works. Starting with the first step, which is acquiring the lock. The method lock basically helps the caller acquire the lock and perform any action like we discussed. And then if the net delta, you can assume the net delta is the net settlement of the currency which is owed by or to the caller. If that is not settled, then the transaction is reverted. Else, the transaction is completed and the lock is released. So this is the method lock. The other one is the pool balance delta, which essentially does two things. So managing the net currency reserves on the pool manager level as well as on the caller level. So you can imagine there are like multiple pool managers, and each are linked to a single vault which has all the token balances. So it's important to update the pool manager reserves because they all kind of map it back to the vault, right? So there are two things which are done in this method. One is updating the pool manager reserves based on the caller action, and the other one is computing the net settlement currency which is owed to or by the caller, right? So the next one is essentially how the transaction happens between the vault and the caller. So there are two key methods. One is take and the other one is settle. The take is used for caller to receive the net settlement from the vault, while the settle is used by the caller to kind of transfer the net settlement to the vault. And now it's also possible to store like surplus tokens in the vault by minting like ERC6909. So you don't need to kind of transfer tokens to and from your wallet to the vault. You can store it within the vault, and you can use it subsequently later for other transactions. So you can mint those ERC6909 tokens and then burn them later to use it. So this reduces a lot of redundant transfer of tokens between the wallets and results in like gas savings. Now, as we discussed, Vault also benefits from flash accounting. So in short, firstly, let's see what flash accounting means, right? So in V3, the typical flow of a multi-hop swap works like so let's say you want to swap like token A for B for C, right? And then at each of these sub transactions, there would be a movement of token B, for example, from or to the pool, and which changes in flash accounting, which is the V4, where all of these transactions happen at once, and then the net balance is finally settled with the caller. So as you can see in V4, only 2 token transfers happen, which is transfer of token A and receipt of token C, while for V3 you can see that token B is received and then transferred again, right? So this kind of leads to gas savings. Now the flash accounting also benefits from transient storage, which is enabled by EIP 1153, recently a part of the ETH Denkun upgrade. So in short, what transient storage does is that it avoids any serialization, meaning that you are now able to store the data temporarily, which is discarded at the end of the transaction, and then you don't need to write or read permanently on a permanent storage, right? So that again saves a lot of gas. Moving on to the next layer, which is the pool manager. So pool manager is something which has the AMM logic, and we have different types of pool manager implementation at launch. The first one is the concentrated liquidity AMM, and the other one is liquidity book AMM. Now the good part is that it's possible to add any other future AMM designs using this layer without any re-implementation of the core protocol. So how it works is that previously in V3 there was a factory contract which used to create different contracts for each of the pools. In V4 all of these pools will sit within the particular pool manager. So pools belonging to the CLMM pool manager will sit inside that, while the belonging to the other AMM designs will sit within that particular contract. What does it? It simplifies the management and creation of liquidity pools, reduces the cost of gas creation by 99%, and also for multi-hop transactions, because now you don't need to move those tokens between different contracts. You can just settle it within the same contract, and that again leads to a lot of gas savings. So the key part here is you can add any AMM logic on the go using this layer. Now we'll look at like how pool managers broadly on a high level, kind of what's the flow with the pool manager. So initially the first thing it does is that we'll check if there's a before swap callback implemented. So this is basically the hooks which we'll discuss later on, but it will check if the before swap callback is implemented according to the flags mentioned initially during pool initialization, and then if there is some implementation, it will execute that logic within the hook contract. Otherwise it will just move on to the next step. It further will then execute, for example, we have taken the example of swap in this particular code snippet. So it will execute the swap logic for the respective AMM type here, and then it will, like we discussed, account for the net balance delta or the net currency that needs to be settled. Further, it will again do the same thing for after swap callback, which will check if there's a after swap callback implemented in the hook contract, and then proceed according to that. So like we were discussing the callbacks previously, the hooks here, which is the custom layer, allows any of so hooks basically are the external contracts which are separate from AMM logics or the core protocol, and it can be deployed by developers, right? So it can be integrated with any of the liquidity pools at initialization, and it's like immutable callback. So once you kind of initialize a pool using hooks with whatever callbacks, then it's not possible to change it. There are 5 key actions from initialize, swap, add or remove liquidity, and donate. And then the callbacks include before and after each of these actions to offer more granular control. Things you could do with hooks include developing order types, dynamic fees, maybe doing some kind of impermanent loss mitigation, and much more, right? So we'll take an example of one of the hook ideas and see how it works. So there's like a VE cake exclusive access hook, and VE cake is a derivative token which is received by the user after staking cake. So the idea behind the hook is that for any of the VE cake holders, only those holders will be able to access these liquidity pools for trading or providing liquidity. So initially we start with inheriting the base hook contract, which is already like you can access that in the hook template we have at GitHub, and then it will kind of inherit that and then reuse the helper methods. Now here, like we discussed about implementing the flags for the callbacks, which is setting it to true or false. So for example, in this particular example, what we need to do is we'll only allow swap for any of the traders who are holding the VE cake balance, right? So thereby will flag it as true and the rest of the other callbacks as false. Now for the before swap callback, we'll implement a logic which will check if the user has any of the VE cake balance, and then based upon that, it will let the user swap within the liquidity pool or not, right? Also on top of it, I am delighted to announce Pancakeswap $500,000 developer program. It will consist of hackathons, cake emission grant program, bounty campaigns, ambassador program, and much more. We'll reveal more details soon. And yeah, this is the biggest program we have ever done for developers and specifically for V4. Yeah, and then for today's hackathon, we have a prize pool of $10,000 distributed across 3 categories. The one is more about like developing a creative hook idea to mitigate the pain points of users, or maybe creating something new. Innovation integration is kind of integrating different DeFi protocol ideas using hooks within the Pancakes and use Pancakeswap as a liquidity layer, or maybe also having a cross-chain liquidity and trading functionality enabled. And tooling and UX improvements include any data analytics dashboards using which has like the metrics, because there will be a lot of pools once V4 kicks in, given each of the pool will have a different hook. So analytics will become a lot of will have more importance and will be required by the users to kind of take a decision on which pools and which hooks to select from. So you can find more details about this on ETHGlobal price detail page on what are the eligibility criteria and what exactly are the maybe some of the project ideas we have shared over there. And yeah, thank you everyone for your time today. This Chef Momo. I have Chef Burger with me and will help you with any Q&A. Thanks. Any questions?
I've joined the workshop in the middle. Sorry for that. But I have a question regarding the hook. Can you re-explain what is it about the hook, please?
Yeah, okay. You want to understand the hooks, right? Yes. Okay, so hooks are, you can assume hooks that previously there's a liquidity pool. There's no possibility to add any other feature on top of that liquidity pool, right? Now so hooks are externally deployed contract where you can deploy certain logics at any of these key actions. So for example, swap, right? There are 2 callbacks which you can implement. So let's say before the swap method is called in that particular, let's say swapper comes to a pool and wants to swap, right? There is a possibility, and that is what hooks enable, that you can implement a logic before swap and after swap. You can define a contract which will implement this logic, and then you can, while pool creation, you can kind of mention this hook contract address. So ideally, every time any of the swapper calls swap, before swap will execute your logic defined in the hook contract, and after swap will also do that. So it's possible to kind of implement any type of logic. For example, let's say custom oracles, right? So you want to, let's say, relay, taking a simple example, you want to create a median oracle which takes the median price of the last 10 data points. For that, you need, on every swap, you will kind of update the latest, you'll fetch the latest pool price, remove the last one, and then take the median whatever price from that, right? So you can keep on doing that, and then anyone else can use that particular hook to get the so it can work as an oracle, right? So you can implement any of the complex logics using that. So we don't need to do any of the protocol re-implementations, and yeah, so the possibilities are like endless. Yes. Yeah. Thanks.
Do you have any example repos for existing hooks that we could use as a template or starting point?
Yes, you can find that at our GitHub. We have also mentioned that in our developer docs, as well as the resources under the ETHGlobal page dashboard. Yeah. Any more questions?
Small question.
Yeah.
Why the mask? Corona is over.
Oh, it's a brand now.
Is it brand? Funny.
Yeah. Yeah, if not, then if you have any questions about V4 or the develop program, please reach out to us at our booth. It's located just at the entry, and then yeah, happy to answer anything. Thanks, everyone. Yeah.
So, hi everyone, I'm Laurent from Gnosis Pay, and we're going to talk a bit about what you can build today on Gnosis Pay during this hackathon. So first of all, what is Gnosis Pay? Gnosis Pay is a Visa debit card, self-custodial, on-chain, which works with stablecoins. And but actually, in a nutshell, what it really is just a safe that is linked to a Visa card. However, our safe setup has a bit of a caveat. It doesn't work. It won't work anymore with your safe web app, and that is because we have some constraints when we want to off-ramp the tokens to the Visa network. And we're going to show you how you can actually still keep interacting with your safe using, the tools that we have available. I think Ben will demo this.
Right, so I'm going to do a small demo, and the demo is basically about how you can keep using a Gnosis Pay safe the same way that you were using a normal safe. And there's going to be two parts to it. First, setting up a safe that works like a Gnosis Pay safe, and the second part is going to be how to interact with that special safe. So I'm going to get started. I'm going to start with creating a safe. Just going to name it. Next, so there's nothing special to do here. Click on create. This is just exactly like you would create any other safe. We're on Gnosis chain because that's where we do Gnosis Pay transactions. And now we're going to need to wait for the transaction. And what I'm going to show you next is how you can set up a specific module, which we call the delay module, to set it up with Gnosis Safe and simulate the same safe setup as Gnosis Pay. So I'm going to go in Apps, Zodiac, click on it, wait a bit, click on Delay Modifier. I'm going to input 10 minutes and 10 seconds here and 10 minutes here. Why specifically those values is not really important right now, but if you want to know more, you can come talk to us later. And this is all, we also have recording of this somewhere, so you can rewatch this. We have like a repo with examples and like videos where we explain the same things. So I'm gonna add this module. And wait again for the transaction. And this is a kind of a two-step process. So right now we're configuring the delay module, but right after I'm going to need to enable it. So there's going to be one more transaction to make this Gnosis Pay safe. Right, this is done. And now we're at the last step of the setup. You can create on the right contract, select enable module, and I need to select, what was it, the address of?
The address that will interact with the delay module. So you can actually just copy it from here.
Right, so the address of the EOA you use to create the module. And then you need to click on bundle transaction, and then you submit the transaction. Again, execute. If during the process you need any XDAI, you can always come and ask us. Last transaction that will set up the safe and make it complete so that you can start interacting with it as if it were a Gnosis Pay safe. Loading, all right.
Should fund the safe.
Oh yeah, funding the safe.
It's like a card without the card.
Yeah, it's it's like setting up the infra so that you can like do the same as what we actually do in the background when we set up a card. That's right. Okay, transaction was successful. And right now, I'm just going to demo how to interact with it. And to do that, I'm going to demo how to do a ERC20 transfer. So, and this can be applied then to whatever transactions you can think of. So Laurent is sending me some ERC20. And I built this little demo app. And there's also, again, a repo that you can, that I will share after. And this repo allows you, it's a small demo on how you can make an ERC20 transfer. So the way it works is you input your safe address. Remove the GNO. I did this mistake 3 times today. And this will get the address of the module that we just deployed right now. And you can find this here in the code. It is here. So in this code, there is a function called getDelayModule that takes in the address of the safe. And you can just like copy paste. Where is it? Yeah, you can just copy paste this in your code and also retrieve the delay module address. Right, so we got the module address. Now the next thing we want to do is execute a transaction. And actually we need to execute 2 transactions. I'm just going to fire this and I'm going to explain like what's happening under the hood. So this is the first transaction. I'm not going to validate it right now because I just really want to explain quickly what is happening. So the first transaction is a transaction against the delay module. This delay module requires to be called 2 times, and we also need to a little bit wait in between those calls. So the first call is a simple, you just point to the delay module address that we retrieved right before. We, bigger? You use the delay mod ABI, which is also as part of the demo example, and you call exec transaction for module with values of the address that you really want to interact with. So in our case, a specific ERC20 address, we hard-coded EURO-E, Ethereum. 0, you don't need to think about this right now. 0 here, and the unsigned TX data that you pass through. So that's what just happened right now. That's the first call that we just saw right now. Now we'll confirm transaction. And we will need to wait, because you actually need to wait a certain amount of time between 2 transactions that you can do to the delay module. And that's where a bit the complexity of this is lying. And it's going to take about 40 seconds. I kind of hard-coded it here. But the real Gnosis Pay delay module works on a 3-minute delay. So in the real-world application, you often need to store this in a DB, keep track of it, and then execute it at a later time. Right, let's go back here. And queue is empty. Oh, okay, so it didn't take enough time. Will it work if I just do it like this?
Yes.
Yes?
Yes.
All right.
Can't you just wait for the transaction to be executed with an async function?
I mean, it's not just about the transaction being executed, it's about the delay module having waited enough time so that you can re-trigger it again.
So how you would actually have to do it is you first execute a transaction to queue the transaction that you actually want to execute. And then once that has settled, then you wait X amount of time. And I think that's where you were getting at, right?
So if I execute it before time, I get null value or empty, or what do I get if I execute it?
It will just be reverted because there is no transaction in the queue.
No, but what will be the response of the value?
Of what value?
From the transaction. I'm guessing that after it's executed, you get a TX? Or?
Yeah, so you get 2 TX. So conceptually, you can think as the first transaction is putting something in the delay mod, and the second is like actually the delay mod, like making the transaction against the safe. And you can see this being executed here, then delayed, and then it's at this moment in time that things will be really executed on chain, on the safe. So in this case, it means that we were able to get some URE out.
No, but my question is if you call it before it gets executed, what will be the response?
I mean, it's just like a TX hash, right? I mean, it will be...
No, if it doesn't have a...
If it doesn't have a TX hash, it will be just null value for the response.
What transaction are you talking about? The one that queues the transaction?
No, the one that queues.
Yeah. You would just have to wait until you actually have a transaction receipt, and then you start the countdown, which in this case is 10 seconds.
Okay.
Yeah.
Thank you.
But we've hard-coded 40 seconds, but the internet was still too slow.
I think that's basically it, right? For the demo part.
So you've seen kind of like how you actually interact with a Gnosis Pay account. This is the only way that you, as your owner of your safe of a Gnosis Pay account, can interact with it. We need to have that delay because we need to make sure that we can settle the Visa transaction before the user can take funds out. So we thought about some bounties and like the problems that we have with this account structure. And one of them is basically allow people, again, to use their safe through the delay module with regular dApps. So one of them could be creating a dashboard that kind of looks like the Safe app and that really allows you to interact with CowSwap or any other DeFi protocols. So it would incur like queuing the transaction and then executing it. And then,
Can I ask a maybe contextual question?
Sure.
So the safe with the delay module represents a card account.
Yes.
And my understanding is that so far in real life that can be used to pay something with, like if you have a UK account, you need GBP stablecoin in there. And if you have a Euro account, you have a Euro stable. So why would anybody want to use that same account to do other stuff? Like if they want to do DeFi degen stuff, why don't they use like the other safe account kind of?
Because we really play, we are a self-custodial card, and we think it's really important that you can use your account for the stuff that you're used to on-chain. And we started out with just 2 stablecoins, depending on your location, EURE or GBPE, but we are planning to expand to other tokens. And for that, you need tooling. You need the safe to be usable. That's the reasoning behind it. And that brings me to the next bounty, actually, or like the other ideas that we had, and that is allow people to use yield-bearing tokens with your safe. And one of the ideas we had, which is something that you can execute on today if you have a Gnosis Pay card, even if you don't, and that is you have yield-bearing tokens somewhere else, let's say in another safe, and you keep an eye on your Gnosis Pay safe, and as soon as that drops below a certain stablecoin balance, you do a swap of the yield-bearing token and you update your card. And that way you can basically keep your tokens at work until the very last moment that you're going to buy your coffee. Yeah. That was kind of like the bounties that we had, so I guess we're going to like open up for questions. Also wanted to tell you that we're hiring developers. If anybody has any questions.
How much do you pay?
We can talk afterwards.
I'm going to ask a newbie question, okay? So you just gave this example of basically making sure that there's enough balance there, but kind of the practical issue is then like what is enough, right? So let's say you put 100 euros and then you go to store and you see something you like for 120 euros, then you're kind of screwed. So what is stopping you from having a more clever way that kind of goes, oops, I need 120 euros. Let's see if there's some other token there.
The ultimate use case would be that you can actually spend yield-bearing tokens. That would be amazing. And you can work on this. It's just that it will require a bit of work on our side as well. So the bounty or the example that we gave, we're going to also look at other bounties, of course, but the example that we gave is the one that is actionable today. However, feel free to work on something where we can spend yield-bearing tokens. And our constraint on our side is that we need to be able to tell Visa, yes, approve the coffee purchase within 2 seconds, and we need to be able to have an assurance of 2 minutes so that we can get X amount of euro, which we approve to Visa, and settle that with Visa. So that's kind of like our constraint. So you need kind of like a quote from a DEX, which is valid for 2 minutes. Yeah.
I don't want to monopolize here, but I think, if you, it's sort of a risk management thing, right?
Yes. Yeah, it is. It is.
So just to summarize the product, so basically it's an off-ramp, a useful off-ramp.
Yes.
Okay.
Yeah.
And then we would convert our ETH to your stablecoin on whatever, Sushi Swap.
Yes.
Okay.
Yeah.
All right. Just.
Yeah. It's a crypto card like you have from Crypto.com or any other centralized crypto exchange, but we offer it in a self-custodial way. So you hold the tokens until the very last minute that you off-ramp them. All right. Follow-up question.
Yeah. I mean, it's self-custodial, but you KYC and you have the control on the Visa side. So you could say...
So how it works is that you give delegate power or delegate access to your safe to us, but with severe constraints on our side. We can only transfer the stablecoin that is used for Visa payments. We can only transfer it to a fixed address, which is a safe controlled by our partner, who is a partner of Visa. And you can only do it within a daily limit that you set yourself.
So then, do I understand the benefit versus Crypto.com? So on Crypto.com, they could say, oh, we decided your KYC was false, so now we block your account.
Exactly.
And you can't withdraw. And if you decide our KYC is
you can still
fake,
access your token.
I can still withdraw.
If Gnosis Pay dies tomorrow, you're still fully liquid. You still have your tokens.
Yeah, that's definitely a far better product.
Any other questions?
Are you gonna share the code base?
Yeah. We're gonna share it. It's already on the bounty page, I think. And if you, we also have a Telegram group chat, so feel free to come to us and we'll add you to the Telegram group chat.
Or I can do it as well.
Or you can go to my colleague Adam. Any other questions? No? All right. Well, thanks everybody for coming and looking forward to the hackathon.
you.